Hi everyone, it's Elizabeth here. In this session, I'd like to review the concepts of confounding versus effect measure modification and the concept of pooling versus standardization. We're going to use the Framingham dataset to look at the relationship between smoking at visit 1 and the risk of death. And we'll use the test of homogeneity to determine whether the relationship between smoking and death is different for different ages. And finally, we'll use data to calculate and interpret a summary estimate that's standardized to the total population, standardized to unexposed individuals, and standardized to exposed individuals. Now, before we get into the actual calculations, let's review the difference between confounding and effect measure modification. Now, as we learned last week, confounding is when a third factor at least partially explains the association, resulting in an invalid estimate. And this is something we'd like to eliminate because what we want to do is get to the true causal effect of exposure and an outcome. So we want to eliminate these third factors that may be explaining part of the association. On the other hand, when it comes to effect measure modification, what we learned this week is that this is actually useful information that we'd like to highlight because this tells us when an exposure has a different effect on the outcome in different groups of people. And in class, we gave an example, personalized medicine. It would be important and interesting to know whether a certain drug were more helpful or more harmful in certain subgroups of the population. Another difference is the idea of scale dependence. When we have confounding of a ratio measure, we have confounding of a difference measure. On the other hand, when it comes to effect measure modification, we may see that the rate ratio for one group is different from the rate ratio of another group, but the rate differences of the two groups are quite similar. So we have to be precise and understand that effect measure modification may be different for different measures. For ratio measures, we may or may not see differences between groups, and for ratio differences, we may or may not see differences between groups. Another difference is how we evaluate the presence of these two concepts. So if we have confounding, if we assume that we understand the correct causal relationship between our factors, if we have confounding, we compare the crude and adjusted estimates. And if the two estimates are different, we would say that they're different due to confounding. And when we're looking at effect measure modification, we look at the relationship between the exposure and the outcome in each subgroup of the population, so in each stratum. And then we do a test of homogeneity to see if these subgroup estimates are truly different. When it comes to presenting our results, in the presence of confounding, we can show the stratum-specific estimates, we can use a standardized estimate, or we can do a pooled estimate like the Mantel-Hansel estimator that we learned last week. On the other hand, if we have effect measure modification, we can calculate a stratum-specific estimate, we can calculate standardized estimates, but we cannot calculate a weighted average of our stratum-specific estimates. Because keep in mind that when there's effect measure modification, there truly is a different magnitude of the relationship between the exposure and the outcome for different groups. Now, if you recall, very early on in the lecture, we were given this excellent quote by a baseball manager. And he said that if you were standing with 1 foot in the oven and 1 foot in an ice bucket, you can't say that overall you're perfectly comfortable. Part of you is too hot and part of you is too cold. So we think about that in the setting of looking at causal effects of exposures and outcomes in epidemiology. One could imagine that if a certain drug were extremely harmful for some people, but extremely beneficial for others, we wouldn't want to say, well, overall in the population, it has no effect, because we know that that overall measure would not be true for anybody. So again, we have these different choices of pooling versus standardization. When we have confounding, we can use a pooled summary estimate, and we can use standardization to address confounding. When we have effect measure modification, we cannot use a weighted average. We cannot use a Mantel-Hansel pooled estimate because that's assuming that the association is similar across the different subgroups. And the only problem is the confounding. On the other hand, when we have effect measure modification, standardization is an option for reflecting the association between our exposure and outcome for a particular population. When it comes to how we take into account these different subgroups, a pooled estimate is simply weighting the different strata to get the most precise estimate to maximize statistical efficiency. On the other hand, for standardization, our weights are chosen to reflect a particular subgroup of the population. And we'll see that in a moment when we start doing the calculations in Stata. And finally, in terms of different examples, one way of doing a pooled estimate was our Mantel-Hansel estimator, and one way of doing standardization could be to standardize to the total population. Another option was to standardize to exposed individuals. Another was to unexposed individuals. And we could also standardize to a different external population. So today what we're going to do is look at that relationship between smoking and death across different levels of age. Now the first thing we're going to do is open up the Framingham dataset and then use the age categories that we've used in previous sessions. Now all of the syntax that I'm going to be presenting today is also included in the handout that you can download from the link directly below this video. So the first thing I'm going to do is open up our Framingham dataset, everybody's favorite by now. And here's the data syntax that we used to calculate the different age groups. We started by setting age for cat to missing. We set it to 0 if a person's 40 or younger. We set it to 1 if a person is 40 to 50. We set it to 2 if a person was 50 to 60. We set it to 3 if a person was older than 60.